R is connected as shown.
You know na this concept?
No.
Okay. You are not aware of balanced Wheatstone bridge?
No.
Okay. So pay attention. What is balanced Wheatstone bridge? Suppose uh, first A B C clear and this is D. So if we take the resistance as P, Q, R, S, and if the ratio of P by R to Q by S are equal, suppose if we consider suppose R all the resistances are equal, or let's take one example 2, 4 and 8 and 16. So P by R is what?
2/4, 1/2.
Same thing is for Q by S.
Yes.
So this is the condition for balanced Wheatstone bridge. So whenever the resistance are in pair, so what will happen? The potential at B will be equal to potential at D. So VB will be equal to VD. So if
VD.
the potential are same, no current will flow.
Yes.
So there won't be the current flow over here. There won't be any current flowing through this. So if the current flowing will be zero, so what will happen? This we can ignore. This resistance can be ignored. So this is the
Yes.
condition for balanced Wheatstone bridge. So same thing we will apply over here. See, now we'll apply same potential method. Now this is the same wire. If the potential at this point is A, even at this point it will be A, na? Same.
Yes.
Okay, but let's try it on with balanced Wheatstone bridge only. So now let's take A over this side. So A, okay. So what I am saying, pay attention. Now we'll form balanced Wheatstone bridge kind. F, A to F. Then so A to F, clear. Then it will be C, D, and E. And then over here it will be B. So just what is the resistance between C and F? It's C and F. It's R. What about C and E? It's also R.
R.
F and D is also R. And D and E is also R. Any resistance between C and D? Yeah, C and D is also R. So as the ratio between this both is equal to this, so we can write like this. This is the case for PQ, sorry, R and S. So P by R is equal to Q by S. So this is the case for balanced.
Balanced Wheatstone bridge.
Hope this concept is easy.
Yes.
Okay, so now no current will flow through this, so we can ignore this resistance. So now can you calculate the equivalent resistance between A and B? So this is
Okay.
already cancelled. So now pay attention. Can we frame the equation like this?
2R plus
2R, good.
it's 2R there, and there's 1R that's parallel. So 1 by R total is equal to 1/2R plus 1/2R, which is 2/2R.
So
One
when
by
we
R.
so uh, parallel resistance we can directly apply. See, whenever equal resistance is there, so it always becomes like this 2R by 2. Or you can do like this.
Yes.
Equivalent RAB will be 2R into 2R upon 2R plus
It will be R.
R.
Hmm.
It will be half. Clear? Are you fine with this question?
Yes.
Should we jump to the next one?
Yes.
Just try it on this one. Okay, three resistances they've given. Three resistance PQR. The bridge gets balanced. They've written the bridge gets balanced. So it's a case of balanced Wheatstone bridge. When this 6 ohms is connected in parallel, the bridge gets balanced. So what we can write? Balanced Wheatstone bridge condition is P by R equal to 2 by 2
Yes.
is equal to 2 by 6s upon 6 plus s. Just solve this.
It is 6s by 6 plus s.
Yeah. So what is the final answer? You have to calculate the value of s.
Okay. S is equal to 3 ohms.
S, S equal to 3.
3.
3. Clear?
Yes.
Even you can do like this. To balance, this has to be 2. Clear, no? To follow this
Yes.
condition P by Q, so 6s upon 6 plus s has to be 2. Even by that way, the answer will be same. Answer is
Yes.
3 ohms. Let's jump to the
Yes.
next one. Write down this one. Same thing, find the equivalent resistance between. The question is find R equivalent between. Everywhere the question is same. R equivalent between
Okay.
A and B. First, always in this kind of question, just write down like this way. A, C, B, B. So A to C, A to C is R, C to D is again R, D to B is again R. Now join this one. So this is also R. But we have an extra resistance in this place, which is parallel again connecting like this. Huh?
Yes.
There is one more this resistance R we have extra. So now this is the case of balanced Wheatstone bridge.
R by 2.
Yeah, final answer is
R by 2.
okay. 1 minute. Yeah, R and R is will be in parallel. Yeah, answer is
Yes.
R by 2.
Hmm.
R
Yes.
A B, and there will be one more resistance R which is in parallel. So the R equivalent will be R into as such uh, R by N. So if two equal resistance are there, the answer is R by N. So R by 2. Okay, fine.
Yes.
So we'll just write on this one.
Total resistance
Same R equivalent between A and B.
5R, right?
5R.
It's in a series.
No, how can it
2R,
be
2R,
series?
R.
It's not connected. Na? Here there is a branching.
Okay. R by 2 again.
R by 2. Okay, let me check. So, in this kind of questions, as I said, we will apply same potential method. So now over here, if the potential, if this over the potential at this point is A, at this point also it will be A because there is no resistance. Even when we
Yes.
go over here, there is no resistance. So at this point also it will be A. Same thing B is over here. B resistance will be over here at same point. This point also there will be B.
Yes.
A and now we will break this, simplify this. So A to B there is one resistance 2R. So I've included this. Now B to A, again there is one resistance 2R, but that is in parallel. 2R. Even this is included. Now A to B, again there is one resistance R which is in parallel. What do you got the answer?
R by 2.
R by 2. Yeah, this is correct. So 2R and 2R, the answer will be R and again R. So answer will be, so first if we consider 2R into 2R upon 2R plus 2R, the answer will be R, and then R and R will be in parallel. How you did?
I did 1 by 2R plus 1 by 2R plus 1 by R is equal to 1 by T.
Okay, you consider all, each and every one in parallel, same way.
Yes.
Okay, so answer is R by 2. Good. Let's try it on this one. Done?
Almost.
Okay.
0.1
0.1? No,
ampere.
no, there is a little mistake. Internal resistance is, you've connected this in series, na?
What in series?
Internal resistance they've given, na? If the galvanometer
Yes.
resistance is 50 ohms,
Yes.
this one. The EMF and internal resistance of the cell are 7 volt and 5 ohms. Where you have
Yes, I
connected?
put that in.
Yeah, so its internal resistance is always connected in series with external
Yes.
resistance. Clear, na?
Yes.
Okay, so where you made mistake. This is the case of balanced Wheatstone.
Yeah.
Okay, so galvanometer will be connected in between. If the galvanometer four arms, the current drawn.
Okay, I did the placement of the galvanometer wrong.
Okay,
Yes.
so the
No
galvan
current will flow
no
there.
current will flow over here. This is 50 ohms.
If
This is 40 ohms and this is 120 ohms. So this will be the simplified circuit.
how's that 40 ohms?
10 plus 30, na?
Okay, yeah. Yes.
So 40 into 120 upon 40 plus 120, which is our. So this is 30.
Yeah.
So 30 and then 5. This will be in series. So total
Yes.
resistances are total is 35.
Yes.
And what's next? V, na? V equal to I into
7.
R.
Ah, yeah.
So 7 equal to I into 35. 0.2.
0.2. Yeah.
You got some 0.1, no? This is the correct.
But the galvanometer won't get anything, right? Because it's in the middle of the bridge.
Yeah, bridge. Galvanometer is always connected in the between, na? So
Yeah, so how will it, since it's a Wheaton bridge, no current will pass through it, right?
yeah.
And the question is how much current will pass through it. So it
In
should be
current
0.
won't pass through in this, but in circuit, so current will flow, na? From here.
Yeah, circuit it will flow.
Okay, so that's why when this galvanometer is connected in between, so galvanometer itself won't take any resistance.
Okay, yes.
Okay, so it won't draw any current. So that's why galvanometer is always connected like this.
Yes.
Okay, so the current will flow and external current answer will be zero point 0.2 ampere.
Yes.
Clear? But galvanometer itself won't take any current. Cut off
Yes.
this one.
Does differentiation and integration come into IGSO questions?
Yeah, differentiation basic IGSO syllabus as such it's very vast. So you can expect differentiation integration also. Yeah, it will be there.
So could we afterwards practice some questions which have differentiation, integration, and electrostatics and motion.
Yeah, sure. So what do you want? Means first you want because you will get, or you know basics, or should I?
I know most of the basics are just some chapters like electrostatics, then current electricity, mainly physics, a few concepts I don't know, but in chemistry I know. So
Okay.
chemistry we can start like papers and solving challenging. Only physics, the concepts need to be done.
Yeah, yeah.
Only few chapters.
So only that's, I think that's why I'm taking very conceptual questions only. I think today's
Yes,
lecture was also like that only.
yes.
Yeah, yeah.
Value of current. Hmm. And I
So this is also the case for
it should be 3v by 10.
which option?
Uh, 3v by 10 if I multiply by x on both sides. No. 'How's it 6 and 9? It's 10 and 5, right?
4 and 2 will, this will be 6, na?
Okay, those are the two.
Then if there is no current over here, so we can eliminate this whole line.
Yes,
So then this will be in series. So 4 plus 2, 6 and 9.
yes. 5 by 18v.
Yeah. So which option?
B.
B. Yeah, that's correct. So V equal to I into 18 by 5. So I equal to 5V by 18. Clear?
Yes.
Okay, just try it on this one.
A and D. Mm-hmm. Mm-hmm. 30 ohm?
30 ohms. So
Yes.
how did you do it? Can you just
Uh,
tell me
s-
the solution?
tell you or send it?
Send it, that would be better.
Yeah.
So in this
I'll
case,
just write the steps down.
yeah, yeah. Or if you can tell me that, then also it's fine. If you
Yeah, so I took that 10 ohm, R1, R1 plus R6, they are in parallel, so that's 5 ohm. Then that
which one? 10
plus
ohms. This which is parallel? R1 and
R6.
okay. So
And that's 5 ohms.
okay,
Then that plus R5, which is in series, so that's 15 ohms. Then I
okay,
went to R2. R2 and R3 are in parallel, that's 5 ohm again. And
okay.
then
And what about
R3
this
and R4 are
resistance?
in series.
What about this one?
They have asked between A and D.
Okay,
So
fine.
the
And
path is
can
like
you just do it with Wheatstone one?
Wheatstone. Okay. Uh, with Wheatstone, that square in the middle, I think that's your Wheatstone bridge.
Yeah. So
Then,
PQRS. So,
then if you find the total from there, and then you can,
yeah. So
add
PQ.
that to the last R4 cut 10 ohms.
Yeah. So P and Q, there is 10. Then Q and R also there is 10. This is included. P and Q is included. P and R. Okay. Okay. Pay attention. So I think this has to be R. Up. Let's try down. P and R. How much? It's 10. And
Everything is done.
R and S is also 10.
Yeah.
Clear? So all each and every resistance are included. And what about this? P and R is also included. Okay. And there will be one more resistance which is 10 ohms over here, and S also there will be 10 ohms.
Yes.
After so A and D na, so this is A, this is D. After Q there is 10 ohms, but they are not asking over here, and even over here
Yes.
also there will be 10 ohms, but this both can be eliminated. Okay, so yeah, solving that will get the answer as 30. Clear?
Yes.
Okay, one minute. Yeah, just try it on. Okay, wait, pen. Just try it on this one first. No, this is still infinity.
And total resistance.
Yeah, total. Yeah, same total resistance between A and D.
Okay. It is 2 by 3 infinite ohms.
No, I don't know how you did. See, in this case, if the total resistance of infinite s- circuits is R, suppose if total resistance of infinite circuits is suppose X, then infinite minus 1 also, the resistance will remain same only, na X. If infinite circuits में से मैं अगर एक कम कर दूंगा तो क्या फर्क पड़ेगा? Understood?
Yes.
So infinite minus 1 will also be X. So suppose let assume that let total resistance or RAB in this case is suppose X. So if I exclude this part, one part, so again it would be same only this remaining infinity minus one part will be same only X. So what I am doing, see, pay
Yes.
attention. Yeah. So this is A, this is B, and this will be X. Hope this part is
Yes.
clear. So now try down
Yes.
and get the answer. So R equivalent will be equal to 1 plus 2 and x will be in parallel. So 2 into x upon 2 plus x. So R equivalent is x only. 2 plus x plus 2x upon 2 plus x. X into x plus 2, 2 plus 3x. X square plus 2x is equal to 2 plus 3x. X square minus x minus 2. So this, when we simplify, we'll get x square. Got the answer? Resistance can't be minus 1. So R equivalent is 2 ohms. Clear?
Yes.
And what answer did you get?
I found 1 ohm plus 1 by 2 ohm. I did it as parallel and I got 2 by 3. Then I multiplied that by infinity. So
Got it.
that. Total.
Okay, okay, yeah, fine. Okay, so now let's jump to the next. Try it on this question.
Hmm. Which one?
Okay, this only, no? Yeah.
Huh.
So basically,
It's a Wheatstone bridge.
this one,
Huh.
there is a new concept also, but for that, one minute. Let me include that question. Suppose, okay, let me explain you one concept. You can do by this way also. So there is a new method. Suppose if this resistance is 2R, 2R, R, again this is 2R. Here it's suppose it's R, and if matlab, if this and suppose this point is B. Okay, so now what the concept is? This is mirror symmetry,
Yes.
or you know this concept,
No.
perpendicular axis of symmetry. So this is a new concept to solve circuits. Na, you can do by this way also. So pay attention what happens. So whenever first you draw a perpendicular bisector from AB. Okay, so you want to calculate the resistance between A and B, correct?
Yes.
So I am drawing a perpendicular bisector over here. Okay, so pay attention. Points on perpendicular bisector. Just write. This is the concept. Points on perpendicular bisector have equal potential. Okay. So points each and every point on this has equal potential. Now you just observe when you cut into two half, the resistance are similar, na? So it's a mirror symmetry or perpendicular axis of symmetry. Hope this part is clear.
Yes.
Okay, clear or not?
Yes.
Okay, so now I will make more complicated and then we will solve it. Suppose if the question was like this, okay, it's as such it's a simple case, sir. This you can do it by a normal way also, 4R, 2R. But what if the resistance over here also there are two resistance? So over here also there is one resistance 2R and 2R. Now how will you do it? So for that reason, what is the concept is points on perpendicular bisector has equal potential. So now this point and this point all are in same potential. So let me name that point M, N and P. So this all are in same potential. So no current will flow at this point. So what you will do? This is 2R.
Ignore it.
Yeah, ignore it. So what I'm doing, sir, just pay attention. I am R. Again, this is R, 2R, 2R, and this is A and this is B. Okay. So just remove this line. This is not connected only. No current is flowing. So there is no this thing. Matlab, there is nothing. 2R current won't flow. So this both can be ignored. So now it's just a normal parallel question. Na? So answer is
Yes.
4R into 2R. So just 4R, 1 by 4R plus 1 by 2R plus 1 by 4R. This is R equivalent. Clear? Concept is clear or confused?
Yes. It's clear.
Okay. So this part is clear. Huh? So now apply this over here. See this also when you cut from between. Pay attention. When you cut from between or perpendicular bisector. Now it's a mirror symmetry or
Yes.
perpendicular axis of symmetry. So what, as I told you, just remove this. So what it will be, pay attention. This is 1 ohm, this is 1 ohm, this is 1 ohm. Okay, but see over here I have not connected. There is a space. Okay, just 1 minute. Okay, pay attention. Now this is 1 ohm. This is not connected. This is 1 ohm. This is 1 ohm, 1 ohm, and this is also 1 ohm. Easy or tough?
Uh,
Just you have to remove this space. See over here also I removed this much line. So remove this line.
yeah, so that 1 ohm should get removed, right?
Yeah,
That resistor through which it passes.
yeah, but which this is passing through this point. Na? There is no resistor over here. If
No, the up on top.
on top, but how? But it's okay. You can do like this. Pay attention. Um, there is no resistance only. So what I am doing, I can do like this also. Na? 0.5, 0.5. Then now now what it will be? If it's passing on perpendicular bisector, but instead of 1 ohm, I have done 0.5 over here and 0.5 over here. So will it get affected?
No.
Okay, so I have kept it in the same way. 1 ohm I have kept like this only.
Okay.
Okay, but the connection at this point will be same. So this point it has to be, to solve this kind of questions. Na, just remove this line. There should be no connection. Yes, I have removed
Okay.
this. So there should be no connection. Now just solve it. So I will give you more practice so you will understand it better way. There are many questions coming. So this is 1 ohm. Now this is also 1 ohm. 2 ohms are in series parallel. So here it will be 2 ohms, 1 ohm, and at bottom it will be 2 ohms. 1 and 2 will be in parallel. 1 into 2 upon 1 plus 2, which is 2 by 3. So 1, 2 by 3, and 1.
Yes.
That will be in series. So 2 by 3 plus 2, 8 by 3 ohms.
Yes.
And that 8 by 3 will be in parallel with 2.
Yes.
Just solve and get the final answer.
8 by 7.
8 by 7. Clear? So 8
Yes.
by 3 into 2 upon 8 by 3 plus 2. So this is RAB, which is 16 by 3 upon 14 by 3. So which is 8 by 7 comes. Easy or tough?
Uh, Medium.
Yeah, okay. I think one will practice now a few questions. I think. See, now pay attention. Now
Yes.
you want to calculate across A and B. Okay. So this line is perpendicular, na? In black. Okay, yeah. So this whole line is the perpendicular axis of symmetry, na? Diagonals bisect at 90-degree in rectangle.
Yes.
So this, what I will do, as such, you can ignore this part. It's very simple. Now get the answer. This resistance and this resistance will get ignored. So it's 2R, 2R, and 2R in parallel. So RAB will be equal to
2R, 2R, 2R.
see if same resistance are in series, suppose if it's 1 by 2 plus in parallel. So if there are three resistance of 2 ohms which are in parallel, so it's the formula is like this: R equal to R by N. In this case, it's 2R, 2R, 2R which are in parallel. So it's 2R by 3.
Is it 3R? The answer.
2R by 3, na?
Final answer.
Final answer only it's 2R by 3.
Okay.
Okay, let me explain. So I think this is A, 2R, 2R, and 2R. This all the three resistance will be in parallel. This much is clear.
Yes.
Okay. Now if this is removed, now two resistance are removed, then so the answer of 2R and 2R will be what? 2R into 2R upon 2R plus 2R. So it's R only. 4R square by 4R. So it's R. So now
Yes.
I don't know where you made mistake. Uh, so A, B, this is 2R, and there is one more parallel resistance which is R. So now take
Yes. 2R by 3.
2R by 3.
Hmm.
Try down next this one. Okay, wait, this is even more tough. Okay, just try down this one.
Okay. This is also perpendicular.
Yeah,
That middle resistor, that won't, we'll ignore that.
yeah.
So 3R, 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 3R by 2, 1.5R.
1 minute. Yeah. Okay. So this will be removed. Yeah. Correct.
Yes.
So it's 3r by 2. That is RAB will be 3r by 2. Okay.
Yes.
1 minute. If there is, try down this one.
Is the small r and big R the same value?
No, that is different in this case.
Okay.
So again, this line will be removed. But pay attention what exactly is when you are solving this kind of question. Because now it's easy because we are just focusing on one concept. But when it comes,
Yes.
so what you have to do, you just have to remove this line from here. So there is 2r, but it is not connected. This is the concept. There is again 2r, but it's not connected on top. This is the concept basically. This is how you have to solve.
Yes.
This is A, this is B. So by default, current won't pass through this.
2r by r plus r.
Correct. So it's 2r by r plus r. So have you so we have all the answers, correct? We know the answers. Now let's try down with another method. Now the another method is this was mirror symmetry or perpendicular axis of symmetry. Now try we will learn this part. Folding symmetry or parallel axis symmetry. Understood? So now folding symmetry, what happens that instead of considering a line over here, if we consider a line over here, now pay attention. So now this won't be actually okay. Now this resistance is there. Okay, so this is not eliminated. Okay, clear. So now pay attention. Now this will come over here. This resistance will come over here. This resistance will come on top and it will be in parallel form. So now pay attention. What will be the how will the diagram will be? It would be A R. This resistance will come in parallel. So there will be one more resistance R. Here it will be 2R. This will come on top. So again there will be one more resistance. 2r, and the next point is B. Now this point will come over here. Now on this point will come over on top of this point. So there won't be any resistance. Huh? Hope this part is clear.
Uh, what won't come on what?
See, when you fold this,
Yes.
just like a paper, just fold this.
Hmm.
So this resistance will come on parallel on this resistor. So R will be
Yes.
parallel. 2R will come
Yes.
on top over here. So 2R will be parallel. And this point
Yes.
will get overlapped on this point.
Yes.
So this will be just a single point. Hope this part is clear.
Yes.
Okay. So now you calculate between A and B. So it would be this RAB will be what? This is in parallel. So it's R by 2. And this again is in
That's R.
parallel R. So R plus R by 2, which is 3R by 2.
3R by 2.
Answer will come out to be same, but the methods are different.
Yes.
In certain case, it would be folding axis of symmetry, and in certain case, perpendicular axis of symmetry. I will give you more example, but first we'll just try down this one. This by folding axis of symmetry. This
I'll
question.
just copy the
Yeah.
points down. Yes.
Copied.
Yes.
Okay. So now we will try the this question also by folding symmetry. Folding symmetry or parallel axis symmetry.
2R and 2R are parallel. R and R are parallel. 2R and 2R again are parallel. No,
Okay.
then series.
So now pay attention. Now there are 3 points. Okay. So now this will,
Can't you fold it vertically?
so then it would be perpendicular axis theorem only, na?
Okay.
That is a different concept. Perpendicular axis, when you are solving, you have to cut from here. You have to cut from here and no current. This is different concept. This is a folding symmetry concept.
Yes.
So how will you do it? So now, okay, let me help you out. A, then there is 2R resistance. This 2R will come on top. So
Hmm.
again 2R. Okay. This 2R, and what about this both?
They'll stay as they are.
Okay. Okay. Again there will be this 2R. This 2R will come on over here. So there is another resistance 2R. This 2R will come over here, and now this is B. Okay. And this R पे कोई folding नहीं हो रहा है ना? So
Hmm.
R will
Yes.
remain like this only. So
Yes.
So now you might be wondering, sir, इसका क्या हुआ? इसको भी तो fold करके. Okay. So now 2R and 2R will be, let's assume
That's
2R and 2R. Let's assume कि वो भी उसके ऊपर parallel आ रहा है and between there is a R. Clear?
yes.
Okay. But now this is the case of P by Q equal to R by S. ये तो balanced Wheatstone bridge है. So this will automatically get cancelled. Easily
Yes.
bouncer जा रहा है.
Understood.
Okay, so now this is the case of balanced Wheatstone bridge. Even this will come on top. So this 2R and 2R will automatically get cancelled by balanced Wheatstone bridge. So the question will be like this. Pay attention. This is R. This is R. This is 2R capital. This is 2R. Again, this is 2R. This is 2R. And all are combining. Okay, the B is point is over here, A point is over here. So 2R, 4R, and 4R will be in parallel. So R equivalent between A and B is 4R or 4R. Answer will be same only. See this condition again.
Yes.
Just copy it so that you should be comfortable with both the ways.
Yes.
Okay, now let's try down this one.
Mm.
Which way you want, parallel or perpendicular?
Perpendicular.
Okay.
Then ignore CF.
Huh?
Then you have to ignore CF
Yeah,
and
ignore
all
CF.
the connections don't happen.
Yeah.
嗯嗯嗯嗯2R.
How come 2R? This also, this all connections won't happen, na? Because the potential at,
Yeah.
so this would be like a Wheatstone only, na? A. So now this both will combine. एक minute, black का now. Okay. So this and this will combine to get 2R.
Hmm.
This and this again you will get same 2R. This and this is also done. This and this. Okay. Now this point also will get eliminated because there is no connection.
Yeah.
We have to break the connection. So now this and this will again be 2R, and this and this again will be 2R. So there are four resistance, and
That, that's equal to 2R only.
no, 2R and 2R parallel will become R if we simplify this as this one. So it would be 2r and 2r will become r and
Okay.
denominator
Yes.
also r. The answer will be r by 2.
I did it like took the resistance for RB and RB